So welcome to the new topic on retrieval augmented generation, which we popularly call as RAG. So when you talk about RAG, as the name suggests, it is retrieval, uh, augmentation, and generation. So the three operations comes in consecutive order. First it retrieves, then it tries to augment, and generation. So let us know about what RAG is in this entire video, and we'll look at the components of RAG followed by the RAG pipeline, how does it work, and without RAG, how will the environment look. So the key takeaways are these. So before jumping into what the concept of RAG is, nowadays we talk everywhere as AI, ChatGPT, Gemini, Perplexity, Claude, and all that. So when you compare RAG with LLMs, uh, you can say that LLMs are going to be an open book exam. So it stops guessing. So once it is an open book exam, it stops guessing and gives accurate answers based on your specific data that you give a prompt. So the prompt searches with the entire database, entire digital repository, and to some extent gives an accurate answer. That is the response that you get it in LLM. So here, analogy, the ultimate analogy you can tag as rags are a brilliant student but forgettable person with a sticky note, with a notes with the student. But whereas when you talk about the LLM, it is like an open book exam. So we closely discuss on the analogy, that the example that we have seen, without RAG, it is like a student, preparing for an exam for the entire year and has no answers questions from the memory. And if you ask about any questions, they try to guess it and make up something based on the digital repository that it searched for. So it leads to some kind of an hallucination, which means that some kind of a fake, not fake, uh, information which would be confusing. So that is what LLM without a RAG. But if the LLMs are incorporated with RAG, it is like a student is given a library card or a sticky note with him and a search engine. And when a question is being asked, the student quickly looks up the exact pages in the document that is being given. It reads them and uses that fresh information to find or to write a perfect or an accurate answer. So, RAG is considered to be a student taking up an exam with a closed document. LLM to be a student taking an exam with an open book. So I hope you understand the usage of RAG and without RAG. So what is RAG? So RAG is nothing but it is a framework that combines the strength of information retrieval and language generation capability of large language model. So in general, it combines the reasoning ability of LLMs with information retrieved from external knowledge sources. So instead of relying only on what the model learned during a training, RAG first finds the relevant information of what it is given, and then it uses it to generate a more accurate or an up-to-date answer. So the two key components of RAG is, one is a retriever component and another is a generator component. So this retriever component is nothing but the information retrieval process, where it finds and ranks the most relevant document or a piece of information from the knowledge base. And the generator component is the one that takes these retrieved information and generate a response using a pre-trained language model. So you can consider RAG to be a combination of information retrieval and LLM generation to produce more accurate answer. So the three steps, core steps of RAG goes on with the retrieval is the first step. Second step is argumentation, and the third step is generation. So when you talk about the retrieval step, it is nothing but fetching of the answer. So when you ask a question to a RAG model with LLM, the system searches a specific database, that is the document that you give it in the prompt. Like you can give a company's PDF or HR policies or private files, your own files. You can attach it to the prompt and you can ask a question. So this question, it will find the most relevant message or information from the document attached. That is the retrieval step. The second step goes with argumentation, where you add context to the answer that is being retrieved. Okay, the RAG model arguments the answer that is being relevant answers that is being fetched during the retrieval process. So it takes those relevant paragraphs and clues them onto your original question. So the third step goes on with it writes the answer. That is the AI. It reads your question plus the glued on paragraphs and writes a neat, natural sounding response based only on that data. So the three steps goes on with retrieval, argumentation, generation, so that you get a more accurate answer. Why do we need RAG? It is an important question to be asked. When you talk about standard AI models, that is the LLM models, the LLMs are powerful, but they have major limitations that this RAG technique could solve. That is, you don't have no more hallucinations. You want to stop all the hallucinations because LLMs they get the answers through some statistical probability from a huge digital repository, and they provide you, you know, the answers, the documents before answering. So it does not have to make things up. It could be a kind of incorrect or a fake answers, or that would lead to confusion. So to stop hallucinations, you can go for RAG, and you cannot guarantee that up-to-date information could be there in an LLM because AI could train for more months, but RAG allows the particular AI to know about things that happened 5 minutes ago because you have just updated the informations or added a new document to the database. So your prompt that you give with LLM with RAG searches within the documents or within the database and gives you a more instant, accurate answers because you have attached the document. And the third thing that LLMs go ahead with is data privacy. That is, you don't have to upload your private company data to a public AI model because all these companies, private data, policies, and all that are very specific to the companies. So your AI just briefly looks at your secure data or the documents to answer the question. So, but when you give it to a RAG, it it secretly preserves those documents. It searches within that document, gives you more appropriate answers that is relevant to the company profile. So for all these things, we need to go for a RAG. So the importance of RAG goes with a traditional information retrieval without a RAG would be like, enterprise with a larger document. And so you use keyword-based search systems to find a relevant document. So when you use a retrieval model without a RAG, user must manually read multiple documents to extract insights, and they have to search results based on the exact keyword matches leading to incomplete or irrelevant information. So, and one more thing is you cannot generate direct answers, only retrieves document. So, to overcome all these, you need to have a RAG added for this information retrieval system. So the real world example goes on with, suppose it is always easy to have an analogy. Suppose think of an HR chatbot. If an employee asks what is our paternity leave policy, okay, so what will the standard AI will do? It'll just check from the repository that is there, and it'll give generally about the leave policies that is available in the net. But if you have a RAG powered LLM, RAG powered chatbot, what it will do is it will instantly search the company's internal handbook and find the section on which the paternity leave policy occurs, and it will reply in the reply in the reply give a reply as a response, like according to page this of that document that has been attached, you get some 6 weeks of fully paid leave. So this is what is the RAG does. The RAG, it searches to the document of the private company leave policies that has been attached to LLM, and it gives you more accurate answers rather than simply searching in the web and viewing the results. I hope it's clear with the example. Now let us move on to uh, RAG versus fine tuning. See, you might ask a question like, is that LLMs with RAG is more essential, or why not we take the RAG model and fine tune it? Okay, that is also possible. Instead of taking a large language model and fine tuning, um, you can work with, but it has got few comparisons with RAG, which is readily available. Let us, move on to um, a system with LLM with fine tuning and a LLM with a RAG. So when you talk about retrieval with a RAG model, it dynamically retrieves relevant external data during inference. So you need not change the model weights. So it adapts to a new information instantly. So you can use a RAG model for the question answer, real time question answering QA, so that the chatbot is accessing your external documents. But when you talk about fine tuning, the other technique, fine tuning your LLM models. So this fine tuning, what it does is it adjusts the model weights by training on its domain specific data set, and it requires a significant computation but improves model specialization. That is, I'll quickly tell about the difference between a RAG and a fine tuning. See, when you talk about RAG, it is again going to be a AI with a search engine to look up for that particular file. But whereas when you talk about fine tuning, as I said, it's going to work with the entire repository with the new data coming up. So ultimately, your power that is being used for fine tuning is higher, and probably the system could be slower because it retrain the model with not an updated information, and so on. But whereas when you talk about the RAG, it is much RAG technique. It's much cheaper because you attach document to it and you ask the particular search engine to search based on that document and give the answer. So probably this using of RAG would cost low, and it is also very instant, and you have an updated informations working under a RAG. So when you talk about the usage of RAG, RAG is mostly used for a question answering scenarios, probably in a chatbot. But whereas when you talk about the LLMs with fine tuning techniques, normally it is best suited for domain specific assistance in the application of sentiment analysis, task specific NLP models, etc. So, what is the key takeaway here? RAG to be used when information changes frequently. But fine tuning, okay, yeah, well, you can use it, but you need that particular model to deeply train on a fixed data set. So that's the difference between RAG and the fine tuning LLM models. So let us now move on to RAG process flow or a RAG pipeline. How does it work? So, as the architecture states, For LLM training, you need a massive data set. So massive data set, you need to pre-train it. You need to pre-train through the LLM. So uh, for training the LLM, of course, the LLMs are being made with the models that statistically computes the probability for given a prompt and it gives you the next prediction. But in RAG, for augmented generation, what you do is you attach a knowledge base to the LLM. So this knowledge base, you use a retrieval model where you first query it into the retrieval model from the knowledge base, and based on the query, based on the search from this knowledge base, this query is again added up with the LLMs that searches from your digital repositories and gives you a response. So the RAG process pipeline works in this fashion. I hope it's clear. So let us quickly move on to the building blocks of how RAG works. So we do as based on the step, first a query is given to an embedding model, that is to an LLM, where that particular query is being stored in a vector database. So this vector database storage happens there, and from there you get a retrieved context. That retrieved context is again given to the LLM. So this LLM, it searches, retrieves from the context of the attached database, and it combines with your LLM to give you a response. So the first is your input, a query prompt, followed by the information retrieval that happens here. So the retriever searches with the external knowledge base to fetch your relevant documents or data. Then it gets the contextual response, that is generator uses the retrieved context to craft a more precise and a quick coherent output. So you get a response here with an enriched, more relevant info. This is how RAG works. So the process goes with, so given a document to your LLM, it chunks the data. This is the detailed process workflow. It chunks the data. Chunking happens. It's nothing but splitting your documents into chunks, a small size text, and that you have a document embedding here. Embedding happens, and then it is stored in a vector databases. So generally, anything, any document that you give to chunks, then it followed by embedding happens, and then it stores in a database. So given a user query, it searches from the query embedding, finds a similarity search, and then based on the similarity, it retrieves your relevant chunks and gives you an answer. I once again want to explain this because this is a more appropriate process workflow that is given a knowledge base to an LLM, chunks the data, then follows a document embedding. The appropriate embedding happens, and then the knowledge base is stored in a vector form, and you tell it to be named as a vector database. So once a user query is been given, it checks with your query embedding, finds a similarity matches, and the appropriate or the more relevant chunks prompts you as a response. This is how the RAG workflow works. So let us move quickly with an example that would work better. Here you build a knowledge base. That is, the knowledge base could be three small text documents. So one document would have a definition of a supervised learning concept. The other document would go with an unsupervised learning, and the third document goes with reinforcement learning. The three documents are given as a knowledge base to a RAG embedded model. So, as said, the process work pipeline. You convert each document into a vector embeddings, that is converted into an embeddings. So the three documents are being represented uh, as a vector representation. So You have any embedding models, you can have a sentence transformer or an OpenAI embeddings, or whatever be the embedding model that you want the documents to be represented, embedded. You embed it, and these embedding vector representation could be stored in a vector database. Either it could be a Chroma DB, Pinecone, or whatever be the vector database. So the third step, again, as per the workflow, it is a query embedding. Here, the user query is, since three documents are attached as a knowledge base to the RAG model. So when a user query comes with what is a supervised learning, so what happens exactly in the RAG model? It is converted this query into a embedding based on the appropriate embedding model, and it is being represented as a vector of this particular form. So a vector of 0.11, 0.82, 0.65, like that it's being represented. And the fourth step goes on with, now the query embedding is being done, it's stored in a vector database. Now the retrieval happens. So this query embedding is compared to all stored document embedding, and using a similarity search, generally it is a cosine similarity, you find the most relevant document. So when a question is asked like, what is a supervised learning? So the similarities goes with the three documents. The document one has got 0.98, the second document has got 0.45, the third document goes with 0.30. So that's uh, what is supervised learning. The first document has got the content with it, and it gives you highest match. So document one is good, right? So now with the definition of what is supervised learning, you need to augment that particular query. See, you retrieve the text, now you have to enhance your query. You need to augment your query. So the retrieve context is the definition. So you need to enhance, and you have to give it to the LLM. So the answers final query to the LLM would be what is supervised learning. So this LLM would throw a supervised learning is a type of machine learning where a model is trained on a labeled data. So this is what argumentation process, that is the second operation called argumentation, comes into a picture. So now the step 6 is the LLM generates the answer. See, RAG goes with retrieval, argumentation, and generation. So under generation, it generates the answer. That is, it passes the query, the question what is supervised learning, plus it will write the text from the document. This combination is given by an LLM, and the response is what we get. Okay, so the final answer could be, the supervised learning is a machine learning approach where a model learns from the labeled data to make predictions. So this answer is obtained using LLM with a RAG technique, where the RAG model searches within the knowledge base, and that is being searched with the LLM to generate an answer. So the summary of RAG steps goes with, store the documents as vector embeddings in a database. You need to convert the second step. You need to convert the user query into embeddings, use appropriate embedding models. Then the third step is to retrieve the most relevant document using a similarity search. And the fourth is the argument the query with the retrieved content, and finally generate the final answers using an LLM. I hope this is clear. Uh, these videos, the information goes with the detailing. As I said, embedding models could be an OpenAI embedding, sentence transformer, Hugging Face embeddings would be one of the vectorization model which converts your text into a numerical text representation, and the storage of all the embedded text should be stored in a vector database, and the vector database could be any of the database, Chroma DB, Pine, Cone, the one with the Facebook AI and all that. Retrieval strategies could be as to find the relevant documents, right? So it could use a similarity search. So general technique, most popular and basic technique would be a cosine similarity or appropriate nearest neighbor ANN technique. And when you talk about the response generation, when you talk about the LLMs could be anything: Llama 3, Mistral FP, Claude, OpenAI Chat, ChatGPT 4, any of the versions of ChatGPTs. And the orchestration framework, how all the components, we manage the flow, is all the framework. Usually we stick on with LangChain model or Llama Index, Haystack, and end-to-end RAG pipeline is being given by Hugging Face transformers or the LangChain RAG chain. So lastly, we move on to the applications of RAG use cases. So RAG use cases are, as said, it could be used in healthcare, in legal issues, where you try to contract clause extraction summarization from legal documents, because you need not go with knowing all the sections in the legal documents. You can use a RAG or in e-commerce or during for an educational purpose or the finance sector. Thank you.